So I'm José M. I'm a researcher at the University of Valladolid. So my background is not in the forestry domain, but I work very closely with forestry people here. And I'm going to speak about the forest ontologies and link open data that were created during the cross-forest project. That was a European project with partners in Spain and Portugal. So I will speak about the source data we had to deal with. I will explain a little bit what is this of link open data, then what were our design decisions to create the forest ontologies and the process to create the data, and so on future work. So the source data, so we have data from Spain and Portugal. The two main kinds of data were forest inventory and land use maps that both countries had, and this is the data we work with in the University of Valladolid. And other partners work with forest fires, that also Spain and Portugal had these data sets, and soil erosion that in this case was only Spain. So the problem with this data is that it was heterogeneous and non-integrated. For example, the Spanish forest inventory had 100 files that were access files, 2 for each Spanish province. They were also complex data, so for the Spanish inventory, we had in total more than 1,000 tables and 20,000 columns that we had to merge and worked with all of them together. And the map forest, there was almost 400 million ones. And this data was not user-friendly, so they used all coordinate reference systems. None of them had coordinate systems that the GPS uses. There were no generalizations, so for example, you could know the species of a tree, but there was nothing about the genus or the family. There were no interconnection of the data, neither among them, nor with external resources. And finally, all this data was described using internal IDs that normally you had to check the documentation to know what they meant. So we wanted to use link open data to try to make this data more usable. So what is this about link open data? So if everyone has heard about link open data, the first thing you heard of is the link open data principles. So the first one is to identify resources using an IRI, which is basically a superset of a URL, which is what you use for our address. Then, since you are using that, be able to reference them. So if you put this IRI in a web browser, it can give you back something. And ideally, what it gives you back is something that describes the resource. And for that, we have a standard that is the RDF language. And using the description, you can link this resource to other resources in your own dataset or to other datasets. And what is RDF? So basically, an RDF dataset is a bunch of triples. So that have the form of subject, predicate, object. And for example, so here we have these prefixes, and we put them here, and there's what we call the namespace of the ARI. So they have all of them are either an IRA or a literal. So if we check this one, for example, it's basically saying that this tree is in a specific plot. This can be seen as two nodes connected by an edge. The nodes represent the resources, and the edge is the property that explains them. And if we use the same IRI, same resource for other triples, so we basically end up with something that is a directed level graph. So we can say that this tree has a position or has a height in meters, or the plot has a position, or the position of the tree is relative to the position of the plot. So as in databases, to be able to give semantics to this is useful to have a schema, but the contrary to databases, the schema is written in the same way as the data, using triples. So in the end, you have a self-descriptive graph. So for example, using vocabularies developed for that, RDFS and all, you can say that this entity is a tree, or this entity is a plot, or more detailed that this tree is, has some species. And you can even use these vocabularies to describe the schema itself. So you can say that a set of species are a subclass of a genus, and a set of genus are a subclass of a family. And in fact, because these languages are based on first-order logic, you can have inferences, and if you have this data in a triple store that has a reasoning capabilities, and you ask for the types of this tree, it will not only give you that it's a tree and the species, but also the genus of the family. And how would you ask this? So you have a specific language for that called Sparkle, and it's very similar to SQL, but it's based on triple patterns, which is basically triples, but instead of an element, you can put a variable preceded by a question mark. And here, for example, you would get all the elements that are a plot and that are in a specific position, and from this plot, all the trees that are in this plot and their height. So using this technology, we developed the technologies, the ontologies and the data. So what we did was a modular bottom-up design. So in red you have the data sets for Spain, and in green for Portugal, grouped by type. So for each of them, we created an ontology to describe the elements. And after we created an upper level of ontology that described the common elements among them. So we would be able to query about common elements in both in kinds of data sets that have similar data. In addition, we have three other modules. One to describe the coordinate reference systems used in the different data sets, and one to describe the positions using the same vocabulary and way of writing, another one for all the measures taken in the data. So, because link open data is about linking, so we linked our resources to external sources, so websites that describe the information, external ontologies, so other people that are already working in the fields, similar fields, they can connect the data and use similar vocabularies, and the same with data existing in external data sets. So for ontologies and data sets, we created connection modules because it's a bit complicated. So depending if it's a data set or it's an ontology, we need to use a different kind of connection modules. And to create the data itself, we used a similar workflow for each data set. So because all the data we use is published by the two countries. So the first part download and decompress the data, then extract it in an intermediate format, normally either CSV or GeoJSON. Then we need to merge the data, because if you remember we have a lot of files for each data set. Then we transform this merged data into RDF, and then finally we enrich this RDF with additional information, such as the coordinates that the GPS uses. So for all this generation, we used a number of scripts, tools, and programs we developed. All of them are open source. Here you have a little summary of the results. So for example, for the Spanish forest inventory, we have more than 1 million trees, around 100,000 plots, and almost 100 million triples. For the Spanish land use, we created 3 different layers with different level of detail, and joining them we have almost 2 million polygons with 72 million triples. All these results are available. So in the case of the forest inventory and use land map, not only the data and the ontologies, but also all the tools used and created to do this. So everything is 100% reproducible. The ontologies, we also publish them in our GitHub, but they are also published in the national data portals of Spain and Portugal and the European data portal. And we also provide a Sparkle endpoint to make this kind of queries I explained. And in the case of Spanish data, they are also provided by the government. There is a link data interface, what I said before about the referencing each resource. So if you go to the IRI that each resource has, you get the information about it using namespaces from the Spanish government. And finally, we have the Forex Explorer. This is a graphical tool to explore this data. So if anyone came yesterday to the event, you could take a look at it. And it's free accessible for everyone. So about the future work. So we are working now in a national project. It's called iuFOR. The main thing we want to do is go the temporal evolution of the data. So we work with the third version of the Spanish forest inventory, and we want to generate link open data for the second and the fourth version, which is being finished right now. While being able to know which tree was the same tree in all three data sets and which plot was the same plot in its three data sets. And also there is a new version of the Spanish forestry map that is also being finished right now that we want to transport. There is not an older version of that, but there is a map of crops and agriculture that has comparable information, so we want to transfer also that. Another thing we want to do is connect with other data sets, starting with the spatial planning data. And there is in fact right now a work in progress with municipalities that you will see just after this presentation. We want to do something with LIDAR data. We are not exactly sure what yet, but we will probably approve it much.